My name is Arnaja, and you're watching Brain Security. We are solving the advent of cyber by TryHackMe, and today is day 22. And the topic for the day is C2 detection, command, and carol. We have understood about C2 servers and C2 communication in one of the previous rooms, but before starting this room, let us have a quick recap. I have found this screenshot from the internet and it basically sums up the idea of C2 communication. Now, C2 stands for command and control. So, what happens in command and control? You have a C2 server and you have a victim machine. You implant some sort of malicious code onto their machine through phishing or physically implanted or any other means, right? And once that malware is implanted and it is initialized or it is just implanted, it sends a confirmation that okay, we are set up, we are all set to the C2 server where the attacker understand the results, and then it sends commands to control this particular machine, right? And this communication keeps on going so that in modern times, just infecting a victim machine is not enough. You also need to keep interacting with it. Like just one time contact is not enough. You need to keep interacting with it, infiltrate some more malicious code, direct how it should execute, and also exfiltrate certain data, credentials, and you have to keep this process continuous. That is why C2 type of communication is crucial for attackers. Yes, that is the gist of what C2 communication is, and it is not like only attackers use this architecture, even developers use this to remotely handle a particular machine or a server. The TBFC is very wary since the last series of attacks by the underlyings of King malware. They are on full alert for anything happening. But they are getting restless. It's too quiet. Sir Elfo of TBFC takes the initiative and proposes to hunt for command and control traffic using meticulously collected network traffic. A majority of the TBFC elves object, we don't have the time to go through so much traffic. So much network traffic. Sir Elfo chuckles. Don't fret, for I have a power tool to assist us. I present to you Rita, that is real intelligence threat analytics. We just need to convert our PCAP file to Zeek logs and Rita will do the rest. Anyone can do it. Just follow today's task. PCAP is a networking practice involving interception of data packets traveling across a network. Most well-known tool is Wireshark. Then we convert it into Zeek logs. It's the world's leading platform for network security monitoring, flexible, open source, and powered by defenders. Learning objectives: convert PCAP to Zeek, use Rita to analyze Zeek, use Rita to analyze Zeek logs, and analyze the output of Rita. And we have VM and split screen. Alrighty, let us see that here. The magic of Rita. Real Intelligence Threat Analytics is an open source framework created by Active Countermeasures. Its core functionality is to detect command and control communication by analyzing network traffic capture logs. Primary features: C2 beacon detection, DNS tunneling, long connection detection, data exfiltration detection, checking threat intel feeds, score connections by severity, show the number of hosts communicating with a specific external IP, shows the date time when the external host was first seen on the network. What is C2 beacon detection? It means that how often does the particular client asks the same thing? If it is something like what are the new commands and some any one command that it keeps on running repeatedly, it detects that. Then we have DNS tunneling detection. That means certain times the attackers try to bypass the firewall by using some hidden data within the DNS request. So it detects that, Rita detects that. Then you have long connection detection. Usually network traffic or network connections are very short, right? But if persistent long connections are detected, it could signal that there is some malware present. Data exfiltration detection, your sensitive or any sort of data is being sent to a particular place. Checking threat intel feeds, already checking flagged IPs and domains that are said to be malicious. Score connection by severity. You find out how malicious can a file be and decide upon that. Show the number of hosts communicating with a Specific external IP. It means how many number of hosts are communicated with a specific external IP or specific external system. Shows the date and time when external host was first seen on network. Now in on the network, if suddenly a new system is connected and maybe suspicious, right? If the server is new and it is rare, it is possibly a risk. We have the magic behind RITA is its analytics. It correlates several capture fields, including IP address, ports, timestamps, connection durations, among others, based on normalized and correlated data set. RITA runs several analysis modules collecting information like periodic connection intervals, excessive number of DNS queries, long FQDN, random subdomains, volume of data over time over HTTPS, DNS or non-standard ports, self-signed or short-lived certificates, known malicious IPs by cross-referencing with public intel feeds or block lists. Majorly all we understood. Over here it said long FQDN. What does FQDN mean? Let us ask Echo. It probably something to do with domain names. If long registered domain names are encountered, they are found to be risky or doubtful. Random random subdomains, self-signed certificates or short-lived certificates, and cross-referencing IPs with block lists. Fully qualified domain name refers to complete domain name for a specific computer, host, or internet. It provides exact location of a resource within the domain naming system hierarchy. FQDN includes the host name and domain name, including all levels of domain up to top level. For example, this and this. Long FQDN can sometimes be cumbersome and may exceed character limits in certain systems, leading to potential issues in network configuration application compatibility. If you're long gibberish domain over here, it might be a bit more suspicious, right? If you have PQRST, A1, ABCD, 123, that kind of subdomain in front of TryHackMe, it will be very suspicious. So those are the things RITA finds out. RITA only accepts network traffic in Zeek log. Zeek is open source network security monitoring tool. Zeek is not a firewall or IPS, IDS intrusion prevention system and intrusion detection system. Main difference: prevention system takes measures to stop that particular intrusion, and detection just alerts the person in charge. It does not use signatures or specific rules to take action. It simply observes network traffic via span ports. Span port, sometimes called a mirror port, is software feature built into a switch or router that creates a copy of selected packets passing through the device and sends them to a designated span port. Used to copy traffic from one port to another for monitoring. Physical network taps or imported packet captures in PCAP format. Zeek then analyzes and converts this into structured enriched output. This output can be used in incident detection response as well as threat hunting. Out of the box, Zeek covers two or four types of NSM data: transaction data, summarized records of application layer transactions, and extracted content data. PCAP, I convert ye to Z logs. Let's get started. A neat feature of Zeek is that it can convert PCAPs into structured logs. If you haven't done so, open the VM, start terminal, navigate to the home directory. Yes, now I can start the machine. The PCAPs directory contains PCAP of real life incidents collected from Bradley's Duncan's blog. He has a wonderful collection of malware related PCAPs that cover real world threats. The Zeek log directory contains Zeek logs. They were created by parsing a PCAP file. Let's parse a PCAP ourselves and look at the output Zeek logs. We will use this command, then examine the logs created, navigate to this directory and list contents. Output should be similar to the one shown below. In the terminal above, we can see that different Zeek logs that were generated. Okay, now analyze this. RITA machine has loaded. Use Zeek read PCAP file output directory command. Oh, through. We have used two commands together over here. First, we change the directory and list the commands. Now analyze this RITA. Now that we have prepared the Zeek logs, we can import them into RITA and unleash its analytics. Enter the command below to import the Zeek logs and let RITA do its work. Once you enter the command, RITA will parse and analyze imported logs. As in the terminal, lot of output is produce. A terminal output was redacted in the example below to keep it tidy. Import RITA logs this database is sync grat. Now that RITA has parsed and analyzed the data, we can view the results by entering the command RITA view database name. Now we enter the command below. Note that it's important to consider the database size. Larger data sets will provide more insights than smaller ones. Smaller data sets are also more prone to false positive entries. The one we are using is rather small, but it contains sufficient data for an initial usable result. Entering the command, we can see structured terminal window with the result as shown below. With it, search bar, we need to enter /. We can then enter our search term and narrow down the results. When we enter question mark while in search mode, we can see an overview of the search fields alongside some examples. The image below shows the help for the search utility. To exit the page, press question mark again. Enter the key escape to exit the search functionality. Results pane include information for each entry that can quickly help us recognize potential threats. Following columns are included: severity, source and destination, beacon likelihood, duration of the connection, subdomains, and threat intel. Whatever we saw over here, the magic that causes the RITA to give the output, those are listed over there. We can see two interesting findings and FQN pointing to, wait, let me first run it. This is the result pane. And what am I supposed to do? We can see two interesting findings and FQ pointing to sunshine something and an IP. The IP address and the URL are defined, meaning this dot is enclosed within square brackets so that when you click on any such links, you cannot be redirected, but actually you can also read the particular link or URL. Move the keyboard arrows to select the first entry. You should then see detailed information in the right pane. And what does it say? Details pane. Apart from the source and destination, we have two information categories: threat modifiers. Threat modifiers, these are criteria to define the severity and likelihood. And we have MIME type URL mismatch, flags connections where the MIME type reported in HTTP doesn't match the URI. This indicates that attacker is trying to trick the browser or the security tool. Rare signature, let me show in the screenshot itself. These are threat modifiers, prevalence and first seen. Then we came to rare signature. Also, unusual patterns that attackers might overlook, such as unique user agent string that not seen in any other connections of the network. Then we have prevalence, analyzes the number of internal hosts communicating with specific external hosts. A low percentage of internal hosts communicating with an external can be suspicious. Only first seen 1 minute ago. Prevalence 2 by 2. 100%. Missing host header, large amount of outgoing data, flex connections that are sending large amount of data out of the network. Connection info, connection count shows the number of connections initiated between the source and destination. Total amount of bytes sent from source to destination. Port number, if port number is non-standard, it warrants further investigation. That is the first flag that you see, first red flag while you see in network communication or network logs, that if unusual ports are used, they are very likely that the service is not legitimate. What is this? Now that we have covered the look and feel of RITA, let's focus on the results displayed. Most of the time, the results that are displayed warrant some attention. Even if entry does not have a high severity score, it can still be an indicator of a compromise. We are using a smaller data set, and this has some downsides. For example, the first seen threat factor is relatively low due to small time frame packets being captured. This can affect the severity score. So any tool that is used for threat detection is more effective if you have large number of data, because you need a lot of data to train the algorithm behind the particular software. In any case, we can still examine the entries and the details and make our own analysis. Let's examine the first entry. The first thing we notice is the long FQDN, this particular domain. A quick search on the virus order indicates that the URL is flagged as malicious. Let us try that out in our native browser. 6 out of 98. Malicious. Go ahead and check the destination IP of the second entry as well. Source, destination. We are lucky to have found known indicators of compromise immediately. However, this is not always the case. Attackers often change the infrastructure and rotate IPs and domain names. Therefore, we should look a bit further when we don't have a hit with known AoCs indicator of compromise. Let's analyze the entries a bit more. When we look at the details pane, we can see some more info. Data included the rare signature threat modifier. This inclusion indicates the combination of certain parameter. For example, SSL certificate details related to this connection is uncommon compared to the rest of the HTTPS traffic. Malware or C2 connections often create unique TLS handshake patterns that differ from those browsers and legitimate clients. Of course, if an attacker wants to carry out the attacker, it is not going to use its own or any other legitimate certificate, right? They are going to either self sign. So, that is one of the detection factors that are used by RITA. And there is not much more we can say about the first entry, so let's have a look at the second entry. IP is malicious according to VirusTotal. The connection duration is quite long. The ports mentioned are non-standard ports. This info warrants further investigation. You can pivot on the information you have obtained and dig into the Zeek logs and PCAP file. This is out of scope for this walkthrough, but feel free to dig into it and find out the information. Just be cautious, as some of the PCAPs may contain malicious files, domains, IPs that are still in use. Each will do his part. Now that everyone has gone through the manual, let's hunt mal rabbits down. We have put a lot of effort into capturing network traffic. Please analyze the PCAPs with RITA and answer the following. Note, use the learn steps to process the PCAP and analyze the RITA. How many hosts are communicating with malware.net? We'll go to search, press forward slash, and write malware.net. Common value must be separated by a colon. We have to convert this Rita underscore challenge into seek logs. Correct? What was the command they said? We are just going to use the exact same one and just modify our particular file. Hit enter. Yes, it is converting the PCAP into Zeek. And next, what we did, we went to our folder and listed if the Zeek log was there. We got it. Next, we are going to import these logs. Rita import logs. Now, for the example, we used asyncrat, but over here we have Rita underscore challenge. So our database and the particular folder will be Rita underscore challenge. Next, we will view that. Yes, now I can finally see what was the question. How many hosts are communicating with malware.net? It says over here prevalence is 6 on 10, meaning the number of hosts that are communicating with this particular domain is 6. And which threat modifier tells us the number of hosts communicating to a certain destination? Prevalence, same thing as above question. What is the highest number of connections to rabbithole This is selected, that means it says connection count for this particular destination, that is 16. No, it also says 16. Are we doing something wrong? Okay, yes, I didn't go up. 40, 38, 31, 40, 38, 29, 21, 18. Which filter would you use to search for all entries that communicate to rabbithole.malhare with a beacon score greater than 70% sorted by connection duration descending? Use the forward slash to go to search module and then question mark character to see the filtered overview. We go to search, we go forward slash, then we go question mark, and it says beacon score and operators are this. We have to use two columns, beacon score and duration, and sorted by connection duration descending. Multiple search criteria separated by space, for example, this. Alrighty, search and destination beacon. Over here they have given sort duration DESC. There we go. Duration is 21 minutes, 70 minutes, 1 second, and beacon score is 97.7. This is the search query we used. Search filter, sorry, not query. In the video, they have also used DST, rabbithole.malheur.net, and then the particular search filter that we used here. But why did that happen? Is not fully satisfied the questions contains. Let's break it down precisely. Search for all entries that communicate to this particular space with a beacon score this. Search for all entries that communicate to rabbit hole. Right, it is written in the question itself. That is why we pre-assumed this. That is actually it does. It only forces this. So this filter would run beaconing traffic to any destination, including host unrelated to rabbit.alrighty. Let us run this as well and see if the output changes. Output wasn't much different, maybe because we have limited data, but we shall keep that in mind. Which port did the host 10.this use to connect rabbithole.malheur.net? 80? It's written here. Yes. And with that, we're done with this challenge. See you in the next one.